Hello there and welcome to Lower 6 Maths A-Level. This is the Applied Practice Paper J. Here we're working on question 6, a mechanics question. The height of a pole vaulter above the ground could be modelled using the equation h equals 1 over 60, 125x minus 12x squared, where h is the vertical height of the pole vaulter and x is the horizontal distance travelled after his feet leave the ground. Find the horizontal distance travelled when the pole vaulter lands. Okay, so what we're going to need to do here is effectively solve this equation, because what we're going to want here is to find out the values here and here at which the pole vaulter lands. Okay, so what we're going to look for here is when the height is effectively equal to 0, what are the values of x? So we're going to get 1 over 60, 125x minus 12x squared, because this is our function that helps us work out the height. And we want the height to equal 0, so we want this expression here to equal 0. We can get rid of the 1 over 60 here to leave us with this. And what we want to do to find out now is our x values when the height is equal to 0. And that will tell us the horizontal distance travelled when his feet leave and touch back down to the ground. So, factorise out x to solve this equation. And now we have two expressions that multiply to make 0. So either x equals 0 or 125 minus 12x equals 0. So therefore x is equal to 125 over 12. So about 10 point something. Let's work it out. We get 10.4. Okay, so find the horizontal distance travelled by when the pole vaulter lands. The answer here is 10.4 meters, because we've got one solution here of 0 and one solution here of 10.4. So given that he effectively launches himself off the ground when x equals 0, and he's going to land after 10.4 meters. Part B, given that the pole vaulter is at greatest height halfway between leaving the ground and landing, so this point here at the midpoint is going to be at 5.2, find the greatest height of the pole vaulter. So what we're going to do here, given that we know that x is equal to 5.2, using our halfway, we're just going to plug in the height of 5.2 into our height function. So we're going to do 1 over 60 times by 125 lots of 5.2 minus 12 lots of 5.2 squared. And this here is going to equal 5.42 meters. So effectively, if this were a graph, 5.2 would correspond to 5.42. This is meters high. Okay. Moving on to the next part. For a jump to be successful, the pole vaulter must clear a height of 4.9. Calculate the range of horizontal distances from the bar that the pole vaulter can leave the ground and have a successful jump. So, given that our maximum height here is at 5.49, we want to find the x values that correspond to a height of 4.9. 4.9? Yeah, 4.9. Okay, so what we want here is the height function to equal 4.9, and what we need here is some height values. So 125x minus 12x squared equals 4.9. So now we've got a quadratic equation here that we can solve and work out x for. So times it over by 60, let me get my calculator, 4.9 times 60, and we're going to get 294. So 294, and let's add the 12x squared onto the left, and we'll take away the 125x onto the right. And this thing will equal 0. So now we need to find the values of x. So grab your calculator, put it straight into that really useful quadratic formula solution mode, and we get, right, let's record these height values. So we get one at 6.83 effectively, and another one at 3.59 effectively. Now what we want here is calculate the range of horizontal values. So the range of horizontal values will be in between 3.59 and 6.83. So therefore the horizontal range is 3.59 meters to 6.83 meters. Okay. State the effect in this model of the model of the pole vaulter as a particle. Well, that's going to imply that it allows a person to be treated as a single mass and allows the effects of rotational forces to be ignored. Yep. And part II, making air resistance negligible. So the effect of air resistance can be ignored, and we can just use this quadratic formula straight away. Okay, so that's 15 marks for that question.